Hello class, in this video I will be showing you how to find the vertical asymptotes of a rational function and how to sketch the graph of a rational function near its vertical asymptotes. Let's begin. Find the vertical asymptote of the function p of x is equal to x squared minus 4 all divided by 2x squared plus x minus 1, then sketch the graph near the asymptotes. I'm going to start by completely factoring the numerator and completely factoring the denominator. So the numerator factors as x minus 2 times x plus 2. The denominator factors as 2x minus 1 times x plus 1. What you'll notice is that there are no common factors in the numerator and the denominator. So what this means is that when we find the values of x that are not in the domain of p of x, those values of x are the location of the vertical asymptotes. Now I'm going to set the denominator equal to 0 to find the values of x that are not in the domain of p of x. Solving the equation on the left, we have x is equal to 1/2. And solving the equation on the right, we have x is equal to negative 1. The vertical asymptotes are x is equal to 1/2 and x is equal to negative 1. So on the grid to the right, I'm going to place two dashed vertical lines. One at x is equal to negative 1, and another at x is equal to 1/2. Now I'm going to test various values of x to determine how the function behaves near its vertical asymptotes. So I'm going to start by testing a value of x that's to the left of negative 1. And I'm going to choose negative 1.1. So I've gone ahead and determined all of the signs of the factors of p of x. In the numerator, a negative times a positive is a negative, and a negative times a negative is a positive. So the result overall is going to be negative. So what this means is that as x approaches negative 1 from the left, p of x approaches negative infinity. So I've gone ahead and completed the rest of the tests, and I'll walk you through it. So if we test x approaching negative 1 from the right, I substituted negative 0.9 in for x because that number is larger than negative 1, and the result is a positive output value. So as x approaches negative 1 from the right, p of x approaches positive infinity. As x approaches 1/2 from the left, I tested 0.4 because 0.4 is less than 1/2, and the result is a positive output value, which means as x approaches 1/2 from the left, p of x approaches positive infinity. And finally, I tested a value of x that was to the right of 1/2. 0.6 is greater than 1/2, so I tested 0.6, and the result is a negative output value, which means as x approaches 1/2 from the right, p of x approaches negative 1/2. So now I'm going to go back to the graph and sketch p of x near its vertical asymptotes. The vertical line on the left is x is equal to negative 1, and the vertical line on the right is x is equal to 1/2. The graph approaches negative infinity as x approaches negative 1 from the left, so the graph will look like this. To the right of negative 1, p of x approaches infinity, so that would look like this. As x approaches 1/2 from the left, p of x approaches infinity, so that will look like this. And as x approaches 1/2 from the right, p of x approaches negative infinity, and that would look like this. And we are done.